Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss binary, half and full subtractor. Let's begin. Binary, half subtractor and binary, full subtractor is one kind of arithmetic circuit. That arithmetic circuit is used in an electronic device to perform arithmetic operations. Basically, half subtractor or full subtractor is used to perform arithmetic operation subtraction in binary numbers. These arithmetic operations are performed by this kind of arithmetic circuits nearly around within 1 microsecond. Millions of arithmetic operations are performed. So, here we discuss binary half subtraction. Binary half subtractor, one kind of arithmetic circuit. So, a logic circuit used for subtracting one data bit from another data bit. Remember, that is one data bit from another data bit without taking care of previous borrow is known as half subtractor. Subtraction from one data bit from another data bit, the condition we don't take care the previous borrow. So, it has no provision for third input. So, what are the methods we have to follow? Subtraction between one data bit to another data bit. In inputs, let x another y. So, the possible inputs 0 when subtracted to 0, 0 is subtracted to 1, 1 minus 0, 1 minus 1. So, in outputs we have the difference d, 0 minus 0 will be 0. At that of case, what be the borrow? Generally, when we subtract one decimal number to another decimal number, a borrow is used for subtraction purpose. Same thing, when 0 is subtracted to 0, the difference is 0, borrow also 0. When 0 is subtracted to 1, so difference is 1, but at that of case we take borrow as 1, 1 minus 0 as 0, borrow 0, 1 minus 1, 1 minus 0, 1, borrow 0, but here 1 minus 1, 0, borrow 0. That is the truth table. It has two inputs, x and y are the inputs, output also two output, one for difference, another for borrow. Look carefully to that of truth table. We have observed under that of column difference d, here 1 1, at that of case either any one of the input is 1 or we can say high, then the output is high, otherwise it will be 0. Next, in case of borrow, that is the input scenario, we have 1, otherwise it will be 0. When we write the truth table in Boolean expressions, from truth table, that is for difference D, is equal to, at which condition we have the output as high, that is 1, that is 1 input, 0 1 for 0, we use primed, for 1 unprimed, so x prime y plus, as you taken the sum of products. Next one 1 0, so x y prime, which is equal to D x prime y plus x y prime, that is x or, so x XOR y. Next, for borrow B, from that of truth table, here 1 input 0 1, so x prime y, so x prime dot y. Now we have D is equal to x or y. So here for that Boolean expression we use XOR gate, XOR gate, and for B x prime dot y, here we use x prime dot y, means x prime ANDed with y, so x prime ANDed with y, that logic gate is used. Now we draw the logic circuit for achieving D. XOR gate is used. It has inputs x, another input y, at output we have the difference as D is equal to x XOR y. Next, for borrow B, AND gate has the input x prime, so this is the x input, NOT gate is used, so the output of NOT gate is x prime, and another input y, output of AND gate to the borrow as x prime dot y borrow b is equal to, this is the logic circuit for half subtractor. Half subtractor. Subtractor. In logic symbol, a half subtractor, it has two input x, another input y, and output difference and borrow. That is the input, that one is the output. This is the logic symbol for a half subtractor. In case of half subtractor, we perform the subtraction of one bit from another data bit without taking the previous borrow, and there will be no provision for third input. That kind of disadvantage can be solved when we are dealing with when we are dealing with binary full subtractor. In case of binary full subtractor, that is also a logic circuit basically used for subtracting one data bit from another data bit along with previous borrow. But in case of half subtractor, there will be no such previous borrow. But in full subtractor, that disadvantage can be solved. We taken the previous borrow bit, therefore it is known as a full subtractor, and it has the provision for third input to take care of a previous borrow. Since we take the previous borrow, so it has a third input. Due to third input, the subtraction may be taken as three inputs. In inputs, it has three inputs, that x, y, another one is bi, which is borrow input. Borrow input bi. So the possible inputs are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So the subtraction is drawn at output section. First we have the difference. The difference d, and difference d is evaluated as x minus borrow input, then subtracted to y. Again, for that subtraction purpose, we have the borrow output b o. When x is subtracted to bi, so 0 minus 0, 0, minus y 0, and borrow also 0. Here 1, borrow 1, 1, borrow 1, 0, borrow out 1, 1, borrow out 0, 0, borrow out 0, 0, borrow out 0, 1, borrow out 1. This is the truth table for the possible inputs having 3 inputs and 2 outputs. The inputs are x, y and borrow input, and output difference and borrow output. From that truth table we can derive proper Boolean expressions. Boolean expressions from the truth table. First, difference D. So D is equal to, where the outputs are high, 1, 2, 3, 4. So there will be 1. So 0, 0, 1. For 0 we use primed, for 1 we use unprimed. So x prime, y prime, bi, x prime, y prime, bi, borrow input, plus here 1, 0, 1, 0, x prime, y, bi prime, x prime, y, bi prime, plus 1, x, y prime, bi prime, x, y prime, bi prime, plus 1, x, y, bi, x, y, bi. That is the sum of product. Now solve that Boolean expression, first rearranging the terms. So x prime, y prime, x, y, bi prime, plus x, y prime, bi prime, x, y, bi prime to x, y prime, bi prime, plus x prime, y prime, bi, plus x, y, bi. From first two terms, bi prime as common. So x prime, y, plus x, y prime, bi prime, plus x prime, y prime, plus x, y. Here we take common as bi. From that of definition of x or get, so x prime y plus x y prime as x or y, bi prime. Again here, that is the definition of x nor get. So x nor y, that bi. So x nor is the reverse of XOR. So we use the prime of XOR instead of x nor. So x nor y bi prime plus that is x or y its prime bi. Use the definition of x or get, so that is x or y or bi. Therefore we have d, the difference, is equal to that one. Next, for borrow out column we can again achieve another Boolean expression. For borrow out, BO is equal to, the output is high 1 0 0 1 means x prime y prime bi, x prime y prime bi plus next one 0 1 0 x prime y bi prime, x prime y bi prime plus 1 0 1 1 x prime y bi, x prime y bi plus here 1 x y bi, x y bi. Now solve it, first rearranging the terms as x prime y prime bi plus x y bi plus x prime y bi prime, that term, plus x prime y bi prime, sorry, x y bi. From first two term taken bi as common, so x prime y prime plus x y as bi as common plus x prime y as common, we have bi prime plus bi, that is x nor get, so x nor y bi plus x dash y bi prime plus bi, that is 1 is equal to x nor y bi plus x prime y, that for borrow out BO. Now using these two Boolean expressions, one Boolean expression for D and another Boolean expression for borrow out, we can draw the logic circuit for full subtractor. First we have D is equal to x or y x or bi, so x or get is used. First we take x or get, it has the input to x, another input y, so the output we have x or y, that is the input towards another XOR gate, and at that another XOR gate it has another input that input is borrow input bi. So borrow input, therefore at output we have d is equal to x, x or y, x or borrow input. Next, for BO we draw the circuit. First x, x nor y, so that is the prime of x or, so when that input is x or xy, when I use a NOT gate here, we have x, x nor y at output. That one is the input towards AND gate, and another input is borrow input. So another input is borrow input bi. So the output we obtain from that of AND gate is x, x nor y and borrow input. Next, another AND gate is used. Another AND gate is used. It has two inputs. One is x prime and y. So achieving x prime, we use a NOT gate here. So the output of that NOT gate, we have x prime, that be the input to that AND gate. Next input y, so y, output of that of AND gate x prime y. These two are the input towards a OR gate, towards a OR gate. So at output of that of OR gate means borrow output, we have x, x nor y dot bi plus x prime dot y, that is the borrow output. From these two Boolean expressions we draw the logic circuit, that is the logic circuit. Logic circuit for what? Logic circuit for full subtractor. Full subtractor. And in logic symbol we perform it as a full subtractor. It has the input, three input x, another input y, another input borrow input bi. It has two output, one is the difference, another is the borrow output. That is the logic symbol for full subtractor. So the disadvantage we obtain from half subtractor can be fulfilled by that full subtractor. So here with the help of this video lecture you understand binary half subtractor, truth table, Boolean expression and logic circuit and logic symbol. Next, binary full subtractor is truth table. It has three input and two output. From that of truth table we express the Boolean expression. By using these Boolean expressions we draw the logic circuit for full subtractor and then logic symbol for full subtractor. So with this useful and informative notes, let me wind up this session. Thank you.